When we compile a C file, there's actually three things going on. First, the C code is passed through a preprocessor which does text transformations, and then that resulting C code gets put into the compiler, which actually does the code generation. And we've been spending most of our effort here in talking about how C gets translated to LC3. So machine code comes out of that. It gets linked together with libraries and other machine code objects to create an executable. So we haven't used the preprocessor much. The only thing we've used it for is for comments. It strips those out, and for pound include. But we're going to talk about, there's lots of nifty things that you can do with that, and we're going to talk about one of them. It's called a macro. And a macro is a way to define a text substitution that happens at compile time. So it happens here in the preprocessor. So the simplest use of a macro is to define a new symbol. This is the macro symbol. We use pound define, and we put the macro symbol, and then we put some text here, which is called the body, that will be substituted for that symbol whenever the preprocessor sees it. So by convention, we like to use all uppercase letters for macros so that they look like macros, and when we're reading the code we have some hint that this is a macro, but it's definitely not a requirement. So when the preprocessor is working through the code and it sees this macro symbol, letters, it will replace the text with that body text here. In this case it's just the number 26. So the source code starts out like this. The programmer writes int hist letters, so he's making a histogram array with one entry per letter. And this is what he writes. And the preprocessor gets to that, and the compiler ends up seeing the number 26 there. It never sees this symbol letters because this has been replaced by the preprocessor. So a macro, it's sort of like a variable, but it's definitely not a variable. It's not in the symbol table. There's no storage allocated for it. It's never actually seen by the compiler. It's not a symbol that the compiler is going to use for code generation. It gets replaced at the preprocessor stage before the compiler starts doing code generation. So it's not a variable. Why would we want to use a macro? It lets us provide a symbolic name for some value that we're going to use over and over in the program. If we want to have, for example, the definition of legal age as 21, there might be lots of places in our code where we make decisions based on whether somebody's age is above or below the legal limit. We can use a symbol for that without allocating a variable for it. It's a constant value. We just want to put 21 here, but if the legal age ever changed, for example, from 21 to 18 or from 21 to 25 or some unforeseen change, we can change this one definition, and we don't have to search through our code everywhere where we're comparing age to 21 and change that value. So it's very good for symbolic names that are used repeatedly. It makes it easy to change in one place in our program, and it sort of automatically changes everywhere that we use that symbol in the program. Okay, so that's nice and good, but there is a more sophisticated use of macros, and we can provide an argument with the macro. So here's a macro that has an argument x. So the macro's name is square. It provides parentheses here, and then we give a symbol to the argument. And there might be multiple arguments separated by commas. And when we specify the body, we use that argument inside the body. Okay, so we're creating a macro to compute the square of a number, and we take that number and multiply it times itself. Pretty straightforward. Now the programmer can substitute any text for this argument here, and that text will be plugged in wherever you see x. This whole body will replace the macro, and the text that's the argument will replace this argument symbol here and here. Okay? So here's an example. Y equals square of m. So this is a macro. We defined it here, pound define square x. So square has one argument, and we put the text m here. Now presumably m is a variable that we've defined elsewhere. What the compiler sees when it compiles is this statement, y equals m times m. It doesn't see this symbol square, it just sees the result of the text substitution that the preprocessor did. Now, all of these parentheses that are here are not required. Okay, this is just part of the body. We can make that anything we want. We'll see later that adding a lot of parentheses is something that macro writers tend to do for safety reasons, and we'll see why in a little bit. Okay, so this thing looks sort of like a function, right? If I see this in code, that looks like a function call. But it's not, because it was defined as a macro and not as a function. So macro is not a function. There's no function call code that gets generated when you see that in the source code. Why? Because the preprocessor has already replaced that thing that looks like a function call with the inline text. So there's no function call, no pushing of arguments, no preamble code, no return statement. None of that stuff is there because it's not a function. The body of the macro is inline. That means it's substituted right there in the code. There's no going somewhere else and executing code. So it's actually inserted into the code right there. The downside is harder to debug. You can't step into a macro because it's not another function, right? So it doesn't make sense. And arguments are not evaluated, right? Because the substitution happens at compile time. And we'll see what that means in a minute. So there's some good things about macros. If it's something very simple, you can do it without incurring the overhead of a function call, but there's some other things to worry about. Dangers with macros. So here's a definition of our square macro, and I left out all of those parentheses. And here I'm going to show you why putting those parentheses in was a good idea. Because when we expand this macro, we take the argument text and we just plug it in, right? We just place it as is. It's not interpreted. There's no understanding whether this is a value or if it's even legal to say. So when we write y equals square n plus 1, this is what it gets expanded to. Y equals n plus 1 times n plus 1. Well, that looks reasonable, but when you think about the precedence rules and the way that the C compiler is going to interpret this, it's m plus 1 times m, because this has a higher precedence than the plus 1. So the result that you'll get is 2m plus 1, not m plus 1 squared. The programmer looks like he intended to compute m plus 1 squared, but this is what actually gets computed. That's a bad thing. So we put parentheses around the arguments often to prevent this thing. So if we had m plus 1 times m plus 1, that would work. That would be what we expected. Here's another case. Y equals 100 divided by square of m. Okay, not bad. Y equals 100 divided by m times m. Again, precedence rules. Times and divide are at the same level, and so we do them left to right. So this means 100 divided by m times m. That's what we're computing, not 100 divided by m squared, which is what you would think the programmer expected when she wrote that. Another problem or issue is that, again, so this text here, we can put anything there. It doesn't get evaluated. So when I say y equals square of foo of m, it means I want to call the function foo with the value m. That's what I want to compute the square of. Well, that might be okay. It gets expanded to this, foo of m times foo of m. Well, look, foo gets called twice. We look at this code, we expect foo gets called once, and then we take that value and we square it. But that's not what we do, because we're not evaluating. It's not a function call. We just do this text substitution, and we do exactly what it says. Foo of m times foo of m. Foo might take many, many thousands of cycles to execute, and now we're going to do it twice for no real good reason. The other thing, what if foo of m has some side effect? Again, we think it's going to happen once, here it's going to happen twice. Maybe we print something to the console or something. So the point is that what it looks like it does here is different than what it actually does when it gets expanded. So you have to be very careful about efficiency and about correctness when you use macros. So they can be handy, but use them very carefully and very judiciously.